You are currently working in a construction yard as a senior welding inspector, during the construction stage of a fixed offshore gas production wellhead platform support frame, jacket. One of your inspectors brings to your attention a crack, which has been detected running along the centerline of a longitudinal welded seam in one of the tubular sections. The material used has a maximum CE 0.45, 25 mm thickness. All longitudinal seams are single U-butts, welded by the SAW process, back-gouged root, welded by the MMA process. Number 1. Which of the following do you consider the most likely cause for this crack formation? A. Excessive loading during construction. B. Lack of restraint during construction. C. Incorrect welding process. The SAW welding process isn't recommended for material of the CE. D. Dilution. The answer is D. Dilution. Number 2. One of your inspectors suggests that the crack formation is due to the fact that an incorrect preheat was applied to the joint prior to welding. A. Preheat will have no or little effect on this type of crack formation. B. Yes, preheat will be one of the main contributory factors to this type of crack formation. C. Yes, preheat is essential to reduce the chances of this type of crack formation as it will ensure hydrogen levels are kept to below 5 ml per 100 grams of weld metal deposited. D. If the preheat was excessively high, it may cause this cracking mechanism. The answer is A. Preheat will have no or little effect on this type of crack formation. Number 3. Which of the following do you consider having contributed to this crack formation? A. Maximum sulfur contents of 0.015% by product analysis. B. Minimum sulfur contents of 0.15%. C. Manganese contents of around 1.3%. D. This kind of crack formation isn't affected by any of the options. The answer is B. Minimum sulfur contents of 0.15%. Number 4. You notice from the WPS that a back-gouged single U-butt weld has been used for the longitudinal welded seams. Do you consider that this joint preparation has contributed to the crack's formation? A. No, this crack formation isn't associated with single U-butt welded joints. B. Yes, with this welding process if the depth-to-width ratio is approximately less than 1.5. C. Yes, with this welding process if the depth-to-width ratio is approximately greater than 2. D. No options are correct. The answer is C. Yes, with this welding process if the depth-to-width ratio is approximately greater than 2. A failure investigation is being conducted on a CMN vessel after it was discovered that cracks were observed in the HAZ and weld metal just before stress relieving was due to take place. The base material is 0.35 C, 1.1 Mn, 0.45 C, 1.2 Cr, 0.48 Mo, 25 mm thick and was welded using the MMA process using qualified WPQRs and WPS. As you oversaw the fabrication process, your input into the failure is required. Number 5. If preheat was carried out on the structure, which the following combinations would be used to establish the preheat temperature? A. Material composition, thickness, and joint type. B. Material composition, heat input, welding position and thickness. C. Material composition, heat input, welding position, joint type, welding process, thickness and electrode type. D. Material composition, combined thickness, hydrogen scale and heat input. The answer is D. Material composition, combined thickness, hydrogen scale and heat input. Number 6. The investigation team questions your understanding of the mechanism involved in HICC. Which of the following combinations of factors are involved to create HICC? A. Temperature above 300 degrees Celsius, susceptible microstructure, hydrogen above 15 milliliters per 100 grams of weld metal and stresses. B. Temperature below 300 degrees Celsius, stresses above the UTS, atomic hydrogen, and multi-pass welds. C. Molecular hydrogen, martensitic Haas structure and stresses at almost Re. D. Stresses above the perlite structure and too high a preheat temperature. The answer is C. Molecular hydrogen, martensitic Haas structure and stresses at almost Re. A structure being manufactured out of CMN steel. The thickness ranges from 15 mm to 50 mm with a variety of joint configurations and welding processes. Your task is to assure that residual stress and distortion are kept to a minimum or rectified. Number 7. In general, distortion can be minimized by A. Using multi-pass welds rather than large single weld. B. Using spray transfer rather than dip transfer. C. Welding around neutral axis. D. Waiting for each weld run to cool fully before depositing the next weld run. The answer is C. Welding around neutral axis. Number 8. When of the following would you expect to have the highest levels of residual stress? A. High-strength low-alloy steel. B. A medium-carbon steels. C. A low-carbon steels. D. All options would be approximately the same. The answer is a high-strength low-alloy steel. Number 9. With the range of thickness for this fabrication, which combination of thickness and joint design would you expect to give the highest levels of residual stress? A. 15 mm thick single V. B. 20 mm thick double V. C. 50 mm thick double V. D. 50 mm thick double U. The answer is C. 50 mm thick double V. Number 10. During and after PWHT, what changes occur to the material and its properties? A. Yield strength falls, residual strength falls, yield strength returns close to original value and residual stress is considerably less than before. B. Elongations decrease, stress increase, elongation and stress decrease to approximately 10%. C. Yield strength increases, stress increase, yield strength falls, and residual stress decrease to approximately 5% of what they were. D. Strain increase, stress increase, strain decrease, and residual stress is 0. The answer is A. Yield strength falls, residual strength falls, yield strength returns close to original value and residual stress is considerably less than before.